Welcome to Maths for You channel, a past question on differentiation and graph sketching from Sri Lankan A-level past paper. Let f(x) equal 9 times x squared minus 4x minus 1 divided by x minus 3 to the power of 3, x not equal 3. Show that f dash x, the derivative of fx, is given by minus 9 times x plus 3 times x minus 5 divided by x minus 3 to the power of 4. Let's do this first part. Fx equal is given, it's the quotient function polynomial, 9 times x squared minus 4x minus 1 as nominator, x minus 3 to the power cube as denominator. So it's fx in the form of u over v. So the differentiation of u over v format is denominator time the differentiation of the numerator. So x minus 3 to the power 3, differentiation of the numerator 9 times 2x minus 4 minus the numerator time the differentiation of denominator 9 times x squared minus 4x minus 1 time the differentiation of the denominator is 3 times x minus 3 to the power of 2. And divided by v squared, denominator squared, which is x minus 3 to the power of 6. I can take 9 as a common, and x minus 3 cube times 2x minus 4 minus 3, so 3 there, 3 times x squared minus 4x minus 1 times x minus 3 to the power of 2 divided by x minus 3 to the power of 6. Still, we can take x minus 3 to the power of 2 as a common. So 9 times x minus 3 to the power of 2 inside x minus 3. But the 2x minus 4, I took 2 out. Therefore, 2 times x minus 2. So 2 times x minus 3 times x minus 2 minus x squared minus 4x minus 1. The x minus 3 to the power squared out is outside the bracket. So and x minus 3 to the power 6. Now x minus 3 to the power squared and x minus 3 squared and x minus 3, 6. We can take the 2 of the power out. The power becomes from 6 to 4. Now 9 times 2, and if I could expand x minus 3 times x minus 2, x squared minus 5x plus 6 minus 3 times x squared minus 4x minus 1 divided by x minus 3 to the power of 4. 9 again, and if I can remove the bracket, 2x squared minus 10x plus 12 minus 3x squared minus plus 12x plus 3. X minus 3 to the power of 4, the denominator is still the same. So if I could 9 times 2x squared minus 3x squared is minus x squared, minus 10x plus 12x is plus 2x, plus 12 plus 3 plus 15. If I can take minus out, minus 9 x squared plus divided by minus is minus 2x minus 15 divided by x minus 3 to the power of 4. And if you could just rewrite it, or just rewrite it, before rewrite it, just the LCM is x 5 3 minus. So just x squared minus 2x minus 15 can be factorized as x plus 3 times x minus 5. So minus 9 x plus 3 x minus 5 divided by x minus 3 to the power of 4. That is exactly what we have been asked to prove. Yes, sketch the graph, the next part. The sketch the graph of y equal fx indicating the asymptotes, y intercept, and the turning points. So we need to find all the crossing the axis and asymptotes and the turning points. So that's a bit of a work. So I just rewrote that the y equal, just wrote it as y equal fx equal the function again 9 times x squared minus 4x minus 1 divided by x minus 3 to the power of 3. Let's analyze it. Just to sketch a graph, we need to get as many points as possible. And the normal format, let's see, when y equals 0, see whether it's actually it cuts the y-axis, sorry, x-axis, the roots of that graph. See whether we have that. So y equals 0. And the denominator, we can ignore it. And I ignore that 9 as well. So what we have, x squared minus 4x minus 1. And from that, that is equal 0. From that, x equal the minus b, that is plus 4, plus or minus square root of b squared minus 4ac divided by 2. That is all these in that square root sign. So 4 plus or minus, and if I can take 4 out, so it says 4 squared is 16, and plus 4, 20. If I could 4 out, is inside square root 5, root 5, inside the square root is 5. 2 out because of 4 become 2 outside the square root. So 2 common. What we have is 2 plus or minus root 5. So the 2 plus root 5, 2 minus root 5. So the graph will cut the x-axis at 2 plus root 5 and 2 minus root 5. So root 5 is greater than 2. So it's in the negative part, and 2 plus this is greater than 4 something. Yeah, plus 4. Right, okay. So we found the root of that function, or that where it cuts the x-axis. So 2 places the graph cuts the x-axis. One is 2 plus root 5, the other one is 2 minus root 5. Right, okay. Now then we see it's again another standard form, x equals 0. So if you could put x equals 0, y equal minus 9 over minus 3 squared and minus 9 over minus 27, that is 1/3. So it cuts the y-axis at 1/3 as well. So x-axis intercept and y-axis intercept, done. Then we need to look at this the function. Always start with this denominator. See whether we have the denominator have x minus 3, because it's multiply x minus 3. It's only we can get x3. If it's x3, it will be going infinity before that. So x3, I just put x3 minus. In other words, slightly less than x3. So the left-hand side of the x3 line, x equal 3 line, x equal 3 line. So x equal 3, the left-hand side of it, if the line is x equals 3, so the left-hand side of it is slightly less. For the application here, or just workout here, the slightly less, we can't actually take 2.99 or whatever. Just take, say, 2, just for a workout, or 2.5 or 2. So if I take 2, so x equal to, that is 4, the nominator, 4 minus 8 minus 1, so it's minus on the top, top minus, and the denominator is infinity, but see whether it's a positive infinity or negative infinity. So x is slightly less, so that is negative. If you look at, say, if you put 2, but it will be 0, but just for the sake of finding the sign, say I put 2. 2 minus 3 is minus 1, that is minus. So minus. So minus over minus is positive. That is why it's positive infinity. So when x equals slightly less than 3, it's positive infinity. So in other words, x equals 3 is an asymptote. The left-hand side, the graph will reach infinity. Y will be infinity on the left-hand side. So the graph will rise to infinity because of positive infinity. Okay, and then x equal plus 3. So just the other side, the right-hand side of the x equal 3 line. So it just, again, for the workout, put x equal 4. So 4 squared is 16, minus 4 times 4 is 16, and minus. So it's just minus. You can simply ask, oh, why don't you put 5 or 6 or something? No, just closer to 3. I'm just putting it 4 to work out. So even less, 3.5 is better. So 4, 16 minus 16 as cancelled out, minus 1. So it's minus the top, and at the bottom is slightly ahead of it, so it's positive. Because of, say, 4 minus 3 is 1, is positive. So negative over positive equal negative, therefore it's minus infinity. So the other side of the graph, the other side of x equal 3, the graph will actually falls to infinity. That's what's a minus infinity, because y reach y infinity. So asymptote is x equal 3. So the first asymptote x equal 3 on the negative side of it, and the second asymptote is still x equal 3, the positive side of it. It will work out when you come to graphs, right? Okay. Next, what we need, we have done this much. The top, we've done it, everything. Yeah. We can, yeah, that's done. Right, let's do this differentiation, which we know we already done in the first part. So minus 9, x plus 3, x minus divided by x minus 3. The turning point is f dash equal to 0 at turning point. The f dash, or differentiation of fx equals 0. If that's the case, ignore that denominator and then minus 9. So all we have x plus 3, x minus 3. So their turning points are x minus 3, x3. So the turning point there. For that turning point, see what the value of y, because we need to get the point. So it's minus 3. If we substitute that minus 3 for x, and we work out all this, I just wanted to get that minus 5 over 6. And then again, plus 5, x equal 5. Again, do that. It's 9 over 2. So we have found the turning points. One is the minus 3, minus 5 over 6. The second turning point is 5 and 4.5, or 9 over 2. We do not know at the moment is the turning point is the maximum minimum. We will come to that analysis later. Right, we have done the y y infinity. Yeah. Let's see the x value, just minus infinity. See what that give us. So if we put minus infinity to the fx, minus infinity is to the power 3 is minus, and on the top is x squared is x squared, infinity squared minus infinity is positive infinity, so it's positive or negative. So x infinity, positive or negative is positive over negative, that is equal negative. So negative minus. So we need to know is actually going to x is infinity minus infinity. Is it above the x-axis or below the x-axis? We need to know, otherwise we can't draw the line, draw the curve or sketch the curve. So then x plus, that is of course the denominator plus, and so plus over plus, that is equal plus. So it's positive. Right, we have done this far, and a bit more analysis, because we need to find a bit more detail. So, right, we have various values. So we know minus 3, so minus infinity and minus 3. So the x between minus infinity and minus 3 is minus, f dash is minus, therefore falling, the graph is falling. So from infinity is falling. Between minus 3 and 0 is rising. So the graph is rising, plus and rising. And in between 0 and 3 is plus again, is continue rising. And 3 and 5 is plus, is rising. And between 5 and plus infinity is, if you substitute that for f dash here, say put some values, then you can find that it's falling. So done. Right, let's start the graph. But got the graph, but do not look at the graph at the moment. I just wanted to go bit by bit, and then establish how I reach to draw the graph or sketch the graph. So I just start from bit by bit. Let's start from the values we have. Y equals 0, x equal values. So this one is sort of slightly more than 4. The other one is minus. So just between something like 0.3. Yeah, okay, here. This value and this value. These are the two places. So 2 minus root 5. 2 minus root 5 and 0 value. And here is 2 plus root 5 and 0. So the two points where that the graph cuts the x-axis, we marked. So that is, if I could number it, then it will be easier for you to understand. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we done number 1. So I wanted to write it down here. This is number 1. These are two number 1s. So we marked number 1. What is number 2? That is the negative side of 3. That's 3 is the asymptote. And positive is actually going to positive. So that is this part. So I wanted to draw this bit only. So this is going to positive. The negative side is going to positive. This is number 2. Then number 3, the positive side of x equals 3, that is negative infinity. So that part is here. That is number 3. Number 4, x equal minus 3. X equal minus 3. That is here. X equal minus 3, and that is a turning point. X equal minus 3, minus 5 over 6. So that is this point. So I know this point. I do not know whether it's minimum or maximum, but just I found the point. That's as 1, and it's all right. That's number 4. And number 5, this one. I'll look at it. Number 5, x equal 5 and 4 over 2. This one. Right. 5 done. Number 6, x tends to minus infinity, and y is minus part of y. So that is this bit. It's minus infinity. It tends to minus infinity. It's below the x-axis because it's minus. The y is 0, but it's minus 0. So that part, that is 6. That is 6. Yeah. And then x positive, but the positive side of the x-axis, y is 0, but the positive side of the x-axis, this one, this bit, that is 7. 7 done. So please only just look at the blue marking only at the moment. So we haven't got the graph yet. So there are bits we know, and the blue marking only at the moment. Right, okay, number 7 done. Number 8. Number 8 is between 3 and minus 3 and minus infinity, which is falling. So we know this point. We know this point. Therefore, the graph is falling. So that bit, just look at the blue only. So that is 8. 8 done. And look at 9. That is between -3 and 0 is rising. -3 and 0, it's rising, this one. And we know the point as well. We already found the point. So that is rising. So it's rising, and cut the excesses and keep rising. But it hasn't reached that y yet. We'll come to that. So 9. Then 10. Sorry, the first one is the y, cut the y-axis, isn't it? So this is first one. So the x minus 3, yeah, that's the one. Sorry about it. We haven't done that x part. Where's that? Y equals 0, that is. I didn't number it, didn't I? So just I would number it A, because I missed the number. So I put A. So this is A, and this is A, not 1. Here, just before that. Yeah, okay. So done. That part done. So just 1 to 9. We have done 1 to 9. 10, between 0 and 3. Between 0 and 3, it's, what does it say? So between 0 and 3 is rising. So that is rise to infinity, reach infinity. So that part done. That is 10. 10. Yes, 0 and 3. Right. 3 and 5 is still rising. 3 and 5 still rising. 3 and 5 here. This is 5. 0 and 5 is rising from this. So it's there. And we know cut in the x-axis, which is A. Yeah. So that missed that from numbering, initial numbering. Right. Okay, that's done. That is what, 11. 11 done. And then 5 and infinity falling. So it's falling this way. So that is 12. It's falling. Yeah, done. So the graph done. So just please let me go through the graph sketching if you want. As I said, I should number here first, but I just missed that. So y equals 0. That's where that cuts the x-axis. So that is, I just marked it as A. Right, this is how I reach the graph. And this coordinates as well. Right. The next part says, let's read the next part. The graph sketch done. The next part is, it is given that f double dash x, or the second derivative of fx, equal 18 times x squared minus 33 divided by x minus 3 to the power of 5. That is given, so we don't need to go through it. And find the coordinates of the points of inflection of the graph y equal fx. So just the points they ask you to find. Right, so f dash x equals 0. And again, as I said, this denominator 18, ignore it. All we have, x squared minus 13 equals 0, because of the point of inflection, f double dash x, or the second derivative, is 0. From that, plus or minus root 13. So minus root 13, 33. That is roughly about 5 something. So minus 5 something. So somewhere here. Let me change the color. Let me change the pen color. Okay. So let's see somewhere here. But it's somewhere here is on the graph. and between the next one, square root of 30 is somewhere between greater than 5, so root root 33, so roughly about greater than 5, say somewhere here is coming up. So it's a point of inflection. So if as the graph's going like that, this graph, what we if you would have known this information, we would have drawn the graph slightly differently. So it's kind of, if you come, and then you sort of turn this way and then come in this way. So this is point of inflection. Point of inflection, which we can do that, just concave down, concave up thing, but we don't go there. But just with the graph, we know how that will be turned this way. So this is point of inflection. And again, this one, you could simply go in this way like that. Is going there. So it's a point of inflection. They haven't asked us to sort of draw it for a point of inflection. That's the points with just for the extra additional information. I just drawn it. So the points of inflection is this concave down, is this concave down, and whichever way you look at it, concave down, the positive side of it. So concave down both. We can work out, but we don't need to go through it with the question. Not looking for that sort of detail, but I just give you a bit more detail to understand if you have come across, or if you will come across the question like this. And if they ask you to sort of draw that and then analyze it as well, how you draw it is a concave down and concave up. But when you come to a question like that, then I'll go through that. Otherwise, thank you so much. Please subscribe to the channel. And very important, if you can help other people, just if you feel that is useful to others, please share with your friends and other A-level students. They may benefit or they will benefit. Thank you.